We're still going to be continuing with independent and dependent events, but really the focus in today's notes is more so of being able to identify whether or not an event is independent or dependent. Because in day one, all we did was I told you what it would be and you were solving for them. Now, the best way to do that is just to start with examples, but I do want to point this out right here, okay? In many cases involving random selection, those would be independent events. And remember, independent is when it does not affect the probability of the other probability. Now, when there is replacement, that's also independent. So what that means is, let's think back to the lemon and lime theory, okay? I gave you an example where we had 2 lemons and 1 lime, and we were taking 2 lemons out of the bag. Well, an independent event would be saying, okay, I have these 3 pieces of fruit. What's the probability of me pulling out a lemon on the first try, which is 2 out of 3? But then I put it back. So if I put it back, we're starting with 3 all over again. It's an all new trial. And then what's the probability of me pulling it out again? Well, that would be 2 out of 3 because I still have 2 lemons in that bag. But something that would be dependent would be when there is not replacement. So that would be exactly as the example was that we had before. What's the probability of pulling out a lemon twice? Well, the first is 2 out of 3 because there were 2 lemons out of the 3 pieces of fruit. But the second was only 1/2 for the probability because I've taken out 1 of the 3 pieces of fruit. I've taken out 1 lemon already. So now that's impacted how many pieces of fruit I have in the bag, which was 2. So now there's only 1 lemon out of 2 pieces of fruit. So you can see how that has impacted the probability of the second event. Let's go through example 3 and just practice identifying independent or dependent. So for example 3, all of these problems deal with having 2 cards that are drawn from a deck of 52. Determine whether the events are independent or dependent and find the probability. So we should all know that a standard deck is 52 cards, labeled A through 10, then we have a Jack, Queen, and King. And we have, so that's 13 cards. And those 13 cards can have different things, like one set of 13 can be hearts, another spades, another clubs, so on and so forth. So there is a total, like I said, of 52 cards. And number 1 is saying we are going to be selecting 2 aces when the first card is replaced. So what we want to do is we're selecting 2 aces and the first card is replaced. That means when I pull 1 card, I want to see what's the probability of me getting an ace. Well, the probability of an ace is going to be 4 out of 52, 1 in each set. Now, when I take this card, I'm going to put it back. So when it's time to draw the second card, I still have 52 options. And I want the probability of pulling out an ace. There once again are 4 aces because I've put in the one that I've selected back into the deck. So because I've put the card back, that means that each event is independent. And then you would just multiply together in order to get the answer. It's okay if you go across the top, across the bottom and simplify, or if you want to simplify these and then multiply. Either way, your answer is going to be 169. Let's take a look at number 2. It says selecting a face card and then a 7 when the first card is not replaced. So I want to find first the probability of getting a face card. A face card would be the jacks, the queens, and the kings. So there's 4 of each of those, which means there's a total of 12 cards. Now, I've taken a card, and it's one face card, and I have not put it back into the deck. So now, when I'm trying to pull my second card, which I want it to be a 7, I no longer have 52 cards in the deck. Instead, since I've already pulled one out, I now have 51 cards in the set. And what's the probability of me pulling a 7? Well, there are 4 7s in the deck. Then you'd go ahead and multiply across the top, across the bottom, and simplify. So that would be 48 over 2,652, and you'd simplify. I'm not really focusing too much on how to solve because I already did a video about that. Now I'm sort of just showing you how to go through and identify. By the way, because this probability did impact this probability, it's a dependent event. This is when we've pulled out a card and that impacted this one. You can see how it's a 51 now instead of a 52. Number 3, selecting 2 hearts when the first is replaced. So I've taken out a card, I've put it back. That would make it independent. So what you should be noticing is replacement means independent, not replace means dependent. So all I have to do is multiply the 2 probabilities together. What's the probability of a heart times the probability of a heart? There are 13 hearts in a set of 52. I've taken the card, I put it back, so there's still 13 cards out of 52 when I go for the second card. You could, like I said, you could simplify if you want to. I like doing that, and then write your answer, or you could have just went across the top, across the bottom, and simplified from there. Up to you. Number 4, selecting 2 hearts in the first card is not replaced. So not replaced means it's dependent. So that first probability will impact the second. What's the probability of selecting a heart? And then the probability of selecting a heart a second time. Well, there are, like we said, 13 hearts out of 52 cards. But for this one, I've taken out a heart and I have not put it back. So now instead of having 52 cards in the deck, I only have 51. But also, there were 13 hearts. I've just pulled out one of them. So only 12 remain. You would multiply those together. And then, like I said, it's up to you. You can simplify first, whatever. We all should end up with the same answer, which is 1/17. Number 5, it says a queen is drawn and is not replaced, and then a king is drawn. So not replaced, keyword. That means we're going to have a dependent event here. So what's the probability of a queen? And then probability of the second card being a king. Well, there are 4 queens in a set of 52. So we have 4 out of 52 for that probability. But now, I've pulled out a queen. I did not put it back. There are only 51 cards remaining in the deck. Now, me pulling out a queen does not impact the amount of kings. So I still have 4 kings in the set. The only way it impacted was the amount of cards. So then just multiply across the top, across the bottom, and simplify, or simplify then multiply, up to you, but we all should get 4 out of 663. Okay. Now, we have a bag that contains 10 beads. 2 black, 3 white, 5 red. A bead is selected at random. Determine whether events are independent or dependent and find the indicated probability. Now, number 6 says that we're selecting a white bead, replacing it, and then a red bead. So replacing it tells me it's independent. That just basically means that we're going to have 10 beads every single time. What's the probability of getting a white times probability of red? Well, there are 3 out of 10 white beads, and there are 5 out of 10 red beads. So across the top, across the bottom, that's 15 over 100, but that does simplify to 3 over 20. Or you could have simplified it first and then multiplied, up to you. Number 7 says selecting a white bead, not replacing it, and then selecting a red bead. So these are dependent. Even though we're pulling 2 different colors, I didn't put it back. So the probability of getting a white bead, we have 3 out of 10. So we had 10 beads, but I pulled out a white one and I kept it because I'm going to use it. So now I only have 9 beads to select from, and I want a red one. So there are 5 red, meaning the probability is 5 out of 9. Across the top, across the bottom, simplify, we all should end up with 1/6. All right, number 8, selecting 3 non-red beads without replacement. So that's dependent. We're going to have 3 probabilities because we're pulling out 3 non-red. So that means that it could be either black or white, just as long as it's not red. So I have 2 black and 3 white. So that means there are 5 non-red beads. So the first one would be 5 out of 10 because there were 10 beads total. Second probability. I've pulled out 1, I didn't put it back, so now I have 9. I also have already pulled out a non-red bead, so I no longer have 5, I have 4. When it's time to draw the third non-red bead, I've already pulled out 2 beads, so there are only 8 remaining. And I've already pulled out 2 of the 5 non-red beads. So that means there's only 3 left to select from. Multiply across the top with all 3, across the bottom for all 3, which gives me 60 over 720, and then simplify. On the homework, I just want to give you some directions. So 8 and 9, you determine if it's independent or dependent and then solve. 17 and 18, same thing, determine if it's independent or dependent and solve. So you're actually going to be writing final answers. But here, 19 through 22, all you have to write is the word independent or the word dependent. You don't have to solve at all. You're just practicing identifying. And then number 11, you identify independent or dependent and you do solve. So you will find the probability and write a final answer. Same thing as before, because this can be challenging, I'm going to make a video and post it after the deadline. So if you really struggled with this, I want you to go back and watch the video when I post it.